Welcome to our video on chemical reactions by Allie, Fairbanks and Miranda, Garcia. Let's start by defining a chemical reaction. A chemical reaction is the change of a substance into a new one that has a different chemical identity. How can I tell if a chemical reaction is occurring? Well, a chemical reaction is usually accompanied by easily observed physical effects, such as the emission of heat and light, the formation of a precipitate, the evolution of gas, or a color change. Absolute confirmation of a chemical change can only be validated by chemical analysts of the products. Next, let's look at the history of chemical reactions. From Wikipedia, we learn that the history of chemical reactions' initial theories of transformation of materials were developed by Greek philosophers, such as the four-element theory of Empedocles, stating that any substance is composed of the basic elements fire, water, air, and earth. In the Middle Ages, chemical transformations were studied by alchemists. They attempted in particular to convert lead into gold, for which purpose they used reactions of lead and lead-copper alloys with sulfur. In the 17th century, Johann Rudolf Goldberg produced hydraulic acid and sodium sulfate by reacting sulfuric acid and sodium chloride. From the 16th century, researchers including John Baptist van Helmont, Robert Boyle, and Isaac Newton tried to establish theories of the experimentally observed chemical transformations. Regarding the organic chemistry, it was long believed that compounds obtained from living organisms were too complex to be obtained synthetically. According to the concept of vitalism, organic matter was endowed with a vital force and distinguished from inorganic materials. Now let's look at an actual chemical reaction using baking soda and vinegar. Then we'll find a practical example of how this can help us in our lives. Baking soda and vinegar is an example of a multi-step chemical reaction. Here's what happens. The acidic acid in vinegar reacts with the sodium bicarbonate in baking soda to form carbonic acid. It's really a double reaction because carbonic acid is unstable and it immediately falls apart and turns into carbon dioxide and water, or what is called a decomposition reaction. The bubbles you see from the reaction come from the carbon dioxide escaping the solution that is left. Carbon dioxide is heavier than air, so it flows almost like water when it overflows the container. What's left is a dilute solution of sodium acetate and water. It effectively neutralizes the acid in vinegar. And here we have the foaming tower of Pisa. Just kidding. As we learned from the baking soda and vinegar example, baking soda does a great job neutralizing acid. Let's look at a practical example that can really help us in our daily life. On the car, you can see that battery acid has built up around the battery terminals. To help maintain good battery maintenance, it is important to remove this acid. Since battery acid can be very dangerous, it is important to neutralize this acid before removing it from the battery. We can do this by mixing water and baking soda at a 50-50 ratio and then applying this to the battery terminals. As you can see, this is an effective way to neutralize and remove this harmful acid. Another great practical example of using baking soda to neutralize acid is to use it to help with stomach acid or heartburn. Mixed with water and swallowed baking soda can help reduce acid and relieve heartburn. In conclusion, chemical reactions have a real application in our lives, and we just saw how to safely remove battery acid from a car or relieve heartburn. Here are a few other examples. There's photographic film. There's a chemical reaction on the film wherever light hits it. There's batteries. Chemical reactions within batteries produce electrons called electrochemical reactions. There's Halloween light sticks. A chemical reaction excites atoms, causing the stick to glow. Fizz is dropping an Alka-Seltzer tablet in water, and it makes a bubbling chemical reaction. Thanks for watching our video on chemical reactions.